Assalamualaikum and hi everyone. Today we will present to you about quadratic function. This presentation will cover the definition, example, real life application and also the exercises. Before we go further, let me explain to you what is the quadratic function. Actually, quadratic function is one of the equation that is in the form of ax squared plus bx plus c, where the a, b and c are the numbers that are not equal to 0. Its equation is expressed by fx equals to a times x minus h in a bracket of square, where it is used to a parabola graph that may open upward or downward as shown in the picture below.
Hi, I am Norizmi binti Othman. I am from AC10. So I'm going to present for example part. For example 1, complete the square and hence sketch the graph of the parabola with equation y equals to negative x squared minus 6x minus 8. For the solution, first step, factor out negative 1 and obtain. So by completing the square, we got y equals to negative in bracket x plus 3 square plus 1. Next, hence the vertex is at negative 3, 1. This is the x-intercept we set, and so we got 0 equals to negative x plus 3 square plus 1. And we got x equals to negative 2 or x equals to negative 4. When x equals to 0, y equals to negative 8, we get the graph is drawn here. For example 2, question asks to sketch the graph of y equals to x minus 4 power of 2 minus 5. We start with the graph of y equals to x squared. Shift 4 units to the right, then 5 units down. For next example, sketch the graph of y equal to x squared divided by 2. Starting with the graph of y equals to x squared, we shrink by a factor of 1/2. This means that for each point on the graph of y equal to x squared, we draw a new point that in 1/2 of the way from the x-axis to that point. For the next example, the question is write the function of fx equals to x squared minus 6x plus 7 in standard form. Then sketch the graph of f and find its zeros and vertex. So the solution is, first of all, we need to solve the problems by completing the square. So from y minus 7 equals to x squared minus 6x, we completing the square by b divided by 2 square equals to negative 6 divided by 2 square equals to 9. So we added 9 on the both side. We get y plus 2 equals to x square minus 6x plus 9. So we got the answer y equals to x minus 3 square minus 2. This is the standard form. Okay, from the result, the vertex of graph of f is 3, negative 2. Next, to find the zeros of f, we need to set f equals to 0 and solve the x. So from the equation x minus 3 square minus 2, we got 3 plus minus square root of 2. Okay, from the result, the vertex of graph of f is 3, negative 2. Next, to find the zeros of f, we need to set f equals to 0 and solve the x. So from the equation x minus 3 square minus 2, we got 3 plus minus square root of 2. And for the graph y equals to x minus 3 square minus 2, we shift the graph of y equals to x square 3 units to the right and 2 units down. That's all for me for example part. Thank you.
Hi, my name is Nurmaisara binti Muaidi, and in this video, I will present the real-life application of quadratic function. Okay, did you know quadratic function is the sole applied in space-time? In space-flight, when a rocket is launched, it also follows a parabolic path. Okay, You can see this is rocket, and when it launch, it will follow a parabolic path. So we can define this shape, parabolic path, with a quadratic equation. And the satellite dish that is designed to receive and transmit information by radio wave also has a parabolic type of shape. Hence, for a parabolic mirror, a reflecting telescope, or a satellite dish, the shape is defined by a quadratic equation. Okay, next I will explain more why quadratic function is also applied in satellite dish. Some elements of a quadratic equation are used when setting up a satellite dish. This is because it involves setting up to certain angles so that it can be able to pick up signal effectively. And then, the dish trap the signal and pass it to a feed horn which now transmit to your TV or a station. Hence, by setting a dish to receive a signal from 2 or 3 satellites at the same time highly involves solving a quadratic equation. That's why quadratic function is very important in concept of satellite dish. Next, quadratic equations are also applied in designing a bridge for stability. The cable that acts as the foundation on the Golden Gate Bridge and many other bridges shape are parabolic. You can see at the picture, the shape is a parabolic. That's why quadratic equations are applied to design a bridge.
Bismillahirrahmanirrahim. Assalamualaikum. I am Hafiz. Okay, I will continue to tell about the real life applications, which is calculating room areas. People frequently need to calculate the areas of room, boxes, or plots of lands. An example might involve building a rectangular box where one side must be twice the length of the other sides. For example, if you have only 4 square feet of wood to use for the bottom of the box, with this information you can create an equation for the area of the box using the ratio of the 2 sides. This means the area, the length times the width in terms of x will equal to x times 2x or 2x squared. These equations must be less than or equal to 4 to successfully make a box using these constraints. The last one for the real life applications is quadratic in athletics. In athletic events that involve throwing objects like the shot put, balls or javelin, quadratic equations become highly useful. For example, you throw a ball into the air and have your friend catch it, but you want to give him the precise time it will take the ball to arrive. Use the velocity equations, which calculates the height of the ball based on a parabolic or quadratic equations. Begin by throwing the ball at 3 meters, where your hands are. Also, assume that you can throw the ball upward at 40 meters per second, and that the Earth's gravity is reducing the ball speed at a rate of 5 meters per second squared. From this, we can calculate the height using the variable t for time in the form of h equal to 3 plus 14t minus 5t squared. If your friend's hands are also at 3 meters in height, how many seconds will it take the ball to reach it? To answer this, set the equations equal to 3 equal to h and solve for t. The answer is approximately 2.8 seconds. I think that's all from me.
First exercises for rewrite in standard form. So this is the questions and also the answer. The second exercises is for the sketch the graph of the quadratic functions below. So this is the 3 questions for the exercises. So this is the answer for questions 1. The graph we obtain is the smile graph opens upwards. This for the second questions, the graph will be open downward, and the third one. Also, the graph will look like this, the open downward. Okay, next here, this is the applications of quadratic functions in real life exercises. So the questions number 1 is about a rock has been thrown from a cliff, and then the head of the rock hit from the cliff to water. The equations are being given here, and this is the sub questions to be answered. And this, so the second question is about here in high school baseball tournament. Messi hit a pitch and the baseball stays in the air. This is the answer for this question. Okay, so yeah, we're done. Okay, thank you.
From the research what we did for technology or application that eventually to talk is symbol lab. We choose these applications because this application is very interesting for me and for us too, which is this application we have a lot of mathematics that we can use from these applications. Okay, for quadratic functions, we know that quadratic functions we need to convert from the general form to the standard form. So by using this symbol lab, we go to this algebra and we go to the polynomial. Okay, for to convert general form to standard form, we need to use the completing the square actually. So here we have a complete square, so we split this. This application will show us like this, complete the square. So for example, I choose this general form, which is 2x squared plus 6x plus 2. Okay, is our general form of quadratic functions. All of this solution is then using the completing square. This we can see how the solutions it makes for us, and it's very easy for us to teach or learn from these applications. So this is a bit step that can we follow from this application, and this is the answer for the standard form for this general form. Not only the step or the solutions only, but this application also show us about graph. So here we can see this application plot for us, which is this application will tell us this standard form for y-intercept, x-intercept, maximum value or minimum value for this graph, and that's why this application is very interesting for me, because it's talks anything for us, how to solve these solutions, how to do the graph and everything. I think that's all from me. Thank you. For the conclusions, first, y equal to a bracket x minus b bracket squared plus q is a quadratic functions in their vertex form, which is similar to the quadratic functions y equal to ax squared plus bx plus k in the polynomial form. Second, the parabola opens vertically upwards when a more than 0 and opens vertically downwards when a less than 0. Third, the parabola has a minimum value when a more than 0 and a maximum value when a less than 0. Fourth, increasing the value of p move the vertex of the parabola to the right horizontally, while it moves to the left horizontally when p is decreasing. Fifth, varying the value of q move the graph vertically upwards when q is increasing or vertically downwards when q is decreasing. And the last one is the vertex of the parabola is given by p and q. That's all from me. Thank you.